All right. All right. So hi guys. So welcome to first week of the seminar. So today's pretty basic. So yeah, these aren't my slides. Assuming you went through the Coursera stuff, you'd know these are the slides from week one. And yeah, credit to Emily Fox and Carlos Guestrin. And I just wanted to go through here and point out some stuff that would probably be relevant to us. Let me get this thing into full screen mode. Okay. All right. So yeah, machine learning is changing the world. I'm going to skip a lot of this stuff. All right. So I just wanted to start here. Machine learning's being used by a lot of these companies. I'm sure you've probably heard of maybe all of these. But Zillow, I want to point out Zillow because the data we're going to be looking at is from Zillow today. It's the one I'm going to use to kind of show you guys more in GraphLab than they did in the videos. And yeah, Zillow is a real estate website that has an automated pricing called the Z estimate. All right, so yeah, basically, you have some data, you're going to apply different machine learning methods, and then based on that, you have intelligence or usable knowledge. Today, we're going to be more in this section. We're not quite at the machine learning yet. All right, so this course, one thing that's the reason why I picked the course is for us to follow is they focus on doing. So every week you're actually applying stuff, and then after doing it is when they talk about the theory behind it. I think that's kind of better because when you just throw people into the mathematics right away, it can be a little bit intimidating. But yeah, so the first case study is very relevant to the Zillow data we're going to look at because it's actually predicting house prices using regression. And then classification. So the difference between, regressions, let me just go back. Okay, regression's more of predicting an outcome, based on say the housing size. Can we predict the price? What's the relationship? Classification is more about the line is, in this case, would be separating data into, in this case, 2 classifications, or you might want 3 or 4 classifications. So it's a little bit different. It's more like finding the border between your different types. All right, clustering. The other example that they gave was document retrieval. Can we put this document into a machine learner and decide whether it's about sports or world news or even legal contracts? There's a lot of different applications. All right, and product recommendation. So this is getting where we're probably applying more than one type of machine learning method to, maybe cluster, I'd say cluster customers into areas based on similar buying patterns, and then give them appropriate recommendations based on their clustering. So yeah, okay, and that's what we're talking about here. Looking at the customers, features about the customers and dividing them, and then features of the products and kind of matching them together. Okay, so this part, deep learning, the thing is, actually in this course, they cut out 5 and 6 for some reason, they dropped it. So really there's only 1 through 4. But I've done some stuff with deep learning, especially TensorFlow, and I believe some other people here have also. So maybe, if we get to this part and we want to do some deep learning, we can put together our own material, I'm sure. All right. Okay, let me, just skip some of this stuff. So this is all just straight from the course. All right, so like I was saying here, matrix factorization and dimension reduction, this part and this capstone, these were omitted. This, I can definitely do some stuff on principal component analysis, which would be one of the dimensionality reduction things. And for the capstone, that would be like, you could think of it like the project that you work on as part of the seminar. A really good one, if anybody wants to join my Zillow thing, I'm going to pitch that later on. All right. So these are examples of regression stuff that we'll go over in the future. Linear regression, regularization, which is a way of preventing overfitting. So yeah, overfitting is like a big thing in machine learning. It's where machine learner will basically just memorize the data that you give it, but then it can't predict anything else. So overfitting, we're always trying to find ways to reduce that. Some examples of algorithms used: gradient descent, coordinate descent. These are, I mean, they're grounded in calculus, but a lot of times it's already implemented in the machine learning algorithm. It's good to understand what it does, and I think later on that we will go into implementing, but right now it's just applying like pre-made packages. All right. So, okay, some example classification algorithms. If you're trying to classify data, can look at linear classifiers, kernels, decision trees. Decision trees is probably one of the simplest here. Boosting is pretty strong. All right, so so here's some more. I'm going to say I've definitely done some of this with the Gaussian and clustering. Latent Dirichlet allocation, okay, that would be new for me as well. So when we get there, I'm also going to be a student. All right. Yeah, so let's move through this quickly. Okay, and this is where I was saying principal component analysis. Actually, I wanted to like give you guys an idea of what that is later on the board when we get to it. All right. Okay, so I'm not doing this part. Okay, so assuming, I would say to be able to follow the seminar well. Well, yeah, so we're kind of targeting like people that would be like scientists, data enthusiasts, or software engineers. We're going to be doing like real projects, coding. I think it'd be good if you knew Python at least, or some kind of programming language. Python's pretty easy. I'm going to assume most people here probably know how to code in Python. This stuff, it's good to have an understanding. I don't know how much of it you would do by hand or anything. But yeah, a lot of the machine learning methods do use these linear algebra, and like gradient descent is based on calculus. All right, yeah, so if you need help with Python, they actually, in week 1, they like showed some basic stuff in the Jupyter Notebook. Yeah. All right, so laptop. Actually, I need a new laptop. Mine's kind of slow with GraphLab. You'll probably see that in a little bit. But yeah, I think if you have 8 GB of data or RAM, you're doing pretty good. Okay. All right, let me go. That might be it for this. Okay, yeah, so anyway, brief overview. That's kind of like what was covered in the Coursera part. All right, and they went through with a Jupyter Notebook, and they did some basic stuff with GraphLab with a kind of tiny data set. It only had like seven like rows of features. So what I want to do with you guys or in front of you guys is I want to load up the Zillow data from Kaggle, and it's a lot bigger. One data set has almost 3 million features. or rather 3 million entries with 50, I think 8 features. So yeah, you'll get a better idea of how GraphLab behaves and actually how useful it is for data exploration. Okay, so let me get out of this. All right, so I'm going to start GraphLab. So if you've used pandas, GraphLab's pretty similar to pandas in a lot of ways. In the video, they claim that it's that it deals with big data sets better. Yeah, not sure if that's the case, but one thing that GraphLab has that's pretty useful is the dot show function that we'll look at. It shows a graphic user interface that kind of gives you descriptive statistics, and you can quickly plot things without writing out code. So yeah.
Does anybody have bicycle downstairs? Oh, my hold on there. Okay. Outside of the building. Okay.
Yeah, like I said, I need a new computer. This thing, what? Not responding? We just look at this. This is awful. So it seems Zoom is taking what precious resources my computer has. All right. Okay. All right, so yeah, they have a terminal you can start, or the notebook. We'll just go right to this. The Jupyter Notebook. Who in here did the first week of Coursera? Thank you, thank you. Yeah, I rushed through the presentation because I wasn't trying to like just repeat the what it had in the course. All right. Okay, so yeah, it's basically like something like Windows Explorer for just finding your documents.
Yeah.
Okay, so here's our notebook. Some of the lines of code, I'll just like kind of say what they are instead of running them, so that I don't take more time than is necessary for it to compute. But yeah. All right. Oh. Okay, so yeah, of course, the first thing you're gonna do is import GraphLab whenever we want to work with it. I just hit Shift Enter because it's already there. While it's loading, let me just talk about this. All right, so these little boxes here, all right, you can select if you want it to be code So this case would be code or Markdown, and you know, Markdown, it's kind of like a it's kind of like an abbreviated web HTML, something like that. But it's just like it has some good fonts and pretty simple to do. You know, like the different size hashes make the font bigger or bolded, like a. And then if you just do Shift Enter on these, it comes out looking pretty good. It's the same stuff you would use for the READMEs and GitHub. All right. All right, so it's still importing. So loading the comma separated value files, the CSV files, see here, the way Zillow provided the data on Kaggle is they just had like all properties in the Los Angeles area, and it's almost 3 million. And with like 58 features, and then in the train file, we're looking at the log error of homes that were sold over a certain period of time. So let's actually down here, yeah, I have like a kind of preview when I loaded it before, and then when you just put the object here and then, you know, hit Shift Enter, it will load, or it'll display like the first few entries. So these are the kind of keys for the homes. Parcel ID, it's like the identifier for each home. And the log error is the difference. It's the log of the error between what Z estimate predicted that the house would be worth. Like, let's say the house, they thought it was worth $500,000, but it was actually, you know, it actually sold for 600,000. So they would generate the error by putting the numerator as the value that it sold for over their estimate. And then, yeah, so basically a positive log error means the house was sold for a higher price than they expected, and a negative error means that it sold at a lower value. I'm pretty sure. It's either that or the other way around. But yeah, so basically we have the log error, and we're trying to predict this value eventually using data points. And we also have the transaction date, which can be a new feature that's not included. So this was the date that this house was sold, January 1st, 2016. Okay, GraphLab is imported. This is great. So all right. Let me get down here. Okay, so the first thing I did is I took the two CSV files and I did an inner join. So an inner join means that it matched the parcel IDs, and then what it did is it only keeps the houses that are in both. So this new S frame that it's making, this feature plus error, it's only going to have the houses that sold, but now they're also going to have, in addition to the log error and the transaction date, they're going to have all those other features that the other data set had, which is like count of bathroom, bedroom count, and all, and square footage, etc. All right, and because of my junky laptop here, I deleted these two objects because they're pretty big. They have, you know, they have a lot of entries and a lot of features, so I just got rid of them because we still have the CSV files if we need to load them later. All right, so rather than, well, okay, I've already saved this S frame as I called it features with error. So this is after you've done some stuff with your object. If you want to save it, this is, you know, the function. It's very simple. Just .save on the SF frame object, and just pass the name of the folder or the name of the file that you want. in here. All right, let me go ahead and load this so that we can take a look at it. Load, okay, it loaded. All right, now let's do this dot show. So this is the part that I think is pretty impressive in GraphLab. So this, the one we're going to be looking at is already cleaned. It already has some stuff done to it. So I want to look at it first, and then I'll just go over briefly like what I did to the data. All right, so here's our parcel ID. So it starts out giving like all the kind of, you know, it gives it the data type, and it gives us the median, mean, standard deviation, and all this stuff. So we really didn't have to write any code to do this, right? We just called a function. Let's look at some of our features that we have. So we have some stuff like air conditioning type ID, architectural style. It kind of shows what's the most frequent. We can see here that 0 is frequent. Actually 0, originally this was a like a 2 quotation marks, but basically I added 0 as the missing value. So the missing values I think can be, we have to put something consistent in there for the missing values, and later we might drop them. But I actually think that because we're looking at error, if we made a feature later by adding up the missing values or something and then creating a new feature, it might be information about the log why error happened. You know, it kind of makes sense. It'd be interesting to look at because it makes sense that if there's less information about the house, it still had, they would predict the wrong price. Right? So it's like an idea. It's a feature that we can make. But the first step to make that feature is going through and changing this value to something like 0 because it's independent value. Let me. What's wrong here? Yeah. Okay. Let's go over to a more interesting feature like number of bedrooms, for example. And then we can look at, actually, yeah, let's look at calculated finished square feet. So this is like the size of the house. So if you click on the name, it has some more things you can look at. So these are numeric or continuous dividers. So you can kind of see like the majority of homes are down here in what, 740 about square feet. And then there's a lot here, and then it gets smaller as it goes up. So generally, a lot of our data is down here. Categorical, I don't think it's going to be too useful on this. Yeah, these are really small percentages. So it's more like a continuous feature. So, but go back. You can kind of look at some different plots to see if, you know, there's any trends that you can see between the different variables. Wow, why is it like this? Okay, so this Windows, it's kind of changed because this I have it plugged into the HDMI cable, and it's kind of changed my screen. This is usually open. Let me see if it changes it if I if I pick something, all right, let's try this, calculated. Okay, there we go. So it opened it up. All right. So this line is the calculated finished square feet, right? Goes up to 8,000, but it looks like this is probably our biggest one. And then you can see the errors. So these are the big errors. But generally, there's not a clear trend, right, in these two features. So yeah, I'm sure that's why they're offering like, I think $1 million to the team that accurately predict error. I'm sure you're agreeing that it's not just a problem. Yeah, so it's like they're offering like some feature engineering in addition to applying machine learning. Let's look at another one. Let's look at one I saw that was kind of interesting was land. It was like a lot size, which is the size of the property. Okay. So the reason why I found this one interesting was all of the errors seem to be on, okay, 0. Basically 0 in this feature means we don't know how big the property is, the land. But if you look, almost all the errors are on the 0 or they're close to it, right? So there could be some correlation between, not knowing the lot size and there being a big mistake when you're predicting the price, or even like for these values that are not 0, but they're a little bit, they're, like 10,000, 15, maybe that's like a building with a lot of stories on a small plot of land, but they didn't know that. So the algorithm predicted it like a single story house. Maybe it's like a 15-story building. This is like, I've looked through a lot of this data and this is probably the first like thing that looked a little bit promising. All right. So, and there's some other things in just heat map. There's bar chart that we can look at. Yeah, and the thing is, like, yeah, there's a lot of features. I haven't looked at all of them. All right, so I wanted to show you guys that, and I guess let me close this one. This thing is disturbing me though. Let me do this. Let's go back to the notebook. Okay. Okay. All right, so basically that data that we just looked at has already been, it's already had a lot of steps done, which are shown here. Like this is, for example, I mentioned how it was the missing values were annotated like with the 2 apostrophes, and then I changed it to 0, and then I might convert the value. Some other stuff that I was doing. Let me object. You can see, if you're familiar with dictionaries, you're calling a column by a key. So our key here is if we say features plus error, and then we index this, the name of the feature, we're calling that column as a S array, I believe is what the data structure is called. And we can apply something. Basically what I'm doing here is I'm calling this column, and then I'm applying a it's cut off, but I'm applying a function to all entries in that column, and then I'm saving it back into that column. So it's very similar to pandas in that way. In this case, I made my own little function because it was just easier to me than going through the documentation, and it was a very simple thing I was trying to do. I was just trying to find all empty strings and, be able to replace the empty string with something else. I could, let me see if I can, okay, this one's showing. Okay, so this is a pretty good example. if you're gonna alter the columns in the course, he just did dot apply, and then he put his like, for example, none to X. He just put none to X in here. When I was doing that with it was running forever. So what I found is that you should actually say lambda X colon and then call it on your X. This is basically saying like for each feature X, apply this function to X. Yeah, so it's in the notebook, but this is the fastest way. The other ones, some of them were, you know, taking like a long time, and then some weren't even completing, and I had to kill the job. So just a piece of advice if you're using GraphLab, because the way he showed it in the course, it didn't really, it probably worked well because his he was only working with 7 like items and not 3 million. All right. And some other stuff that I did to clean the data. Removing columns. So the reason I removed this column is there were like 98,000 and I think only 16 of them had this feature. So it's not really useful. If we only know building class type ID of 16 out of that, that's like probably, I didn't check the statistics, but it's probably less than 0.1%. It's not going to give us meaningful information on a big scale. So I just deleted it. And there wasn't other information I could really grab out of that feature. And then there's other features, some other stuff in data cleaning. Some features are redundant. Like they had like bathroom count, and then they had 3/4 bathroom count, and then they had like whole bathroom count, and I don't know. Basically, I merged them into one feature because we don't need all that. That's a good question because Zillow didn't really. It seems I know their algorithm's proprietary, so like I don't think they want people to know exactly how they found. So that's why they're making the competition predicting the error because so I think they just kind of dumped like public data from LA, like maybe the county or something. Yeah, but we could look at that in a little bit, but it's possible. Yeah, so this is an example of, this is where I merged the bathroom. See, we have bathroom count, calculated bathroom number, full bath count. And I explored these and it looked like these two were almost identical. And then this one is like the integer. And then this one is a 3/4 bathroom, which I guess is in the data dictionary. It says it's a bathroom that doesn't have a bathtub. It just has a shower. And so basically I just tried to combine them. And the other reason is I'm trying to isolate the truly missing information. So like say if one of the houses has a value in here, but it doesn't have a value in here, it's not really missing, right? So I just moved it all into one column.
Wait, so you merged all the half bathrooms together with the full bathrooms?
Yeah, basically, yeah.
That's gonna give you like that's gonna skew your data.
Yeah,
I mean, it's a big difference when you buy a house where the when they say like 2-bedroom, 2-bath, or it says two bedroom, 1.5 baths.
Yeah.
Like the price, there's a huge price difference.
Yeah, that's true. Well, I kept it as a float. So I mean, what I mean is like I merged it into one value, but I added them. So like if it said half bathroom or 3/4 bathroom, then I added that to the full bathroom. So it would be like 1.75. So I still kept that accuracy, but I just put them together because I was trying to figure out which houses truly have no number. Like this, what is it? This feature, calculated bathroom, is supposed to be, according to the data dictionary, that's like all of the houses, or I mean, sorry, all the bathrooms added together, but there was discrepancies. So I think it's just kind of poor data entry. I think it might be government data or something. So I just tried to use the other features to you know, put all the information in one place. All right, and I don't know, what else did I do? So every time I remove a column, yeah, because I remove these bathroom columns because for this first one, I'm trying to, what I'm planning to do with this data, or the purpose of the way I'm cleaning it is to make that feature that really shows what we don't know about the house. Because I want to see if there's any correlation between lack of knowledge and the log error. Maybe, you know, because it's just a hypothesis, but I think the more missing data from the house, the bigger the error is going to be, because it means they don't know as much, or the algorithm doesn't know as much. But I didn't get to that part yet. I guess the only thing I did here that could be called feature engineering, and it's not a very impressive engineering, is I just took the absolute value of the log error, because I was running out of time. I was like doing this at 5 a.m. and I just wanted to go to sleep. So I was like, all right, our feature engineer making a new feature. Yeah, in this case, we're just gonna take the absolute value of the log error, because that will show, I still kept the log error, but I think absolute log error is interesting because it's the magnitude of the error, and we might, you know, find a correlation that doesn't matter whether we undervalued or overvalued it. I want to do one that's like counting the missing values, and then later I want to do some principal component analysis, which is more advanced, but because this was just week one and I was trying to keep it really, really basic. But yeah, so that's really, in sum, that's kind of what I did so far. All right, is there any like other questions so far? You know, the log error, actually, let's look at that, because on Kaggle, they like listed how they, yeah, they have the mathematics up there. So let me just close these. Yeah, so we'll just move to the next part before, you know, just going out to chat about whatever we want, which is I'm going to be working on this Kaggle problem with Zillow. And, you know, so Kaggle is this competition website. You build machine learning algorithms and you get ranked. You can have teams of up to 3, and then I believe later you can merge the teams. So like if we had like several teams, we could all work on it kind of on our own, and then we can merge later and you know, use all the stuff that we've come up with. And basically you can place in the rankings. It's possible to win money. It's also possible that you could just get noticed by, I don't know, maybe a startup looking for someone to do some machine learning work for you or for them or something. And they might notice that you keep showing up in the competitions and you're doing pretty well. So it's just a way of like building your online presence. All right, let me minimize this. Okay, so as you guys can see, I haven't done much on Kaggle. I've done some tutorials, and this Zillow will be the first like real competition that I tried. All right, so we go to competitions. And then there's more than one competition. So if any of you guys aren't interested in this housing one and you want to try one of these other competitions, you know, check it out. There's so many.
Is there any like specific reason why you choose Zillow?
There's a few reasons. One of them is it lined up really well with this course. So you know, the course that we're kind of using for the seminar. The other reason is 7 months to go. So it means there's enough time that even if there are, I'm assuming not everybody in here is like expert at machine learning. So there's some time for us to learn and also to apply what we learned. So that's one of the things I was looking at, because some of these are like, what, 11 days to go? There's no way we're gonna like do anything in 11 days. I mean, I looked at this one. This is deep learning using pictures, images, but you're like, they want you to use their software, Intel's software, and it's like you have to learn a whole new interface. But yeah, there's a bunch of, these are all options, but they have shorter time frames. The interesting thing about this is for one, data about houses is probably pretty intuitive, because we all like have probably rented a house at least, or and lived in houses. So we can look at the features and we can kind of use some of our intuition to come up with ideas. Whereas some of these other things are really abstract. Like this is like medical treatment, But yeah, that's why I picked it, because I think it aligned with beginners somewhat. So yeah, Zillow, they provide like a pricing algorithm. Like for example, it's called the Z estimate. Or no, so yeah, they'll have a price and then they'll give the Z estimate, which is based on a machine learning algorithm. And what we're calculating is the error. We're trying to predict the error that it has for real transactions, right? Evaluation, this is where your question will come up. You said you were asking how log error. Okay, so it looks like log of the Z estimate minus the log of the sale price, which is the same as the log of the Z estimate as the numerator and the sale price as the denominator. So I think that's the opposite of what I said earlier, right? So that means if the Z estimate is high, the log error will be positive. And if the Z estimate is low, then it'll be negative.
Means the actual
Right. Right. The transaction, because all of that's like public record, so they can grab that and then compare it to their what they thought the price would be. And the way they're so like we predict on, we have like a training set that we predict on, the ones that I did the inner join on, and then we test it by submitting it to Kaggle, and then Kaggle has some other transactions, I believe, from these months, October, November, December of 2016 and 17, which they're hidden, right? So all it'll give back to us is it'll tell us the percentage that we got correct, or I believe the percentage accuracy. So we're supposed to generate this kind of output. Like it has the parcel ID, and then it has a prediction of the log error for each month. So that is what month the transaction happens is part of the consideration, like of what the value would be.
What kind of data are provided? What data?
Well, the data we were looking at in the Jupyter Notebook, that was the main data they give. And I believe the rules for the first round is that we're not supposed to use outside data. So like we have, longitude and latitude and all the other features, but I don't think we're supposed to like go on Google Maps and find out if this is waterfront, for example. They said
Global financial
yeah, that would still be outside data. Like I think for round one, they just want us to use what they provide, which is let me go to data. So this train is that one I was showing you with the log errors, and then this is the one that had all those features like bedroom count, bathroom count. All right, this is just a sample of what our submission file should look like, formatting. And then there's a Zillow data dictionary that just kind of, it's not, in some cases, it's not all that great at explaining what the feature is, but it gives you an idea of what each feature means. But yeah, so basically the data we were just looking at in the Jupyter Notebook, that's what they give. and then they said after round 1, if you make it into the top 100 teams for round 2, then you can use outside data. So then you can, you know, check for waterfront and all that stuff.
So basically, you're just going to build some sort of regressional analysis, right?
I think like I mean, we can definitely do some regression. Like next week in the Coursera course is regression, and we could probably like just use it for fun. But I think this problem is going to be a lot more complex. I haven't seen anything that looks like linear like correlation. So I think we're going to have to I don't know. We're gonna have to try a lot of things, which is why it goes well with the course. We try this and try that. Maybe we'll find something.
I think what they're trying to, for the submission, validating, they are like testing like time series data, right?
Right. Well,
time series predictions. That's what they're testing.
Yeah. Basically, they want you to give a prediction for 6 different months, and then basically it's going to evaluate your prediction on the month that the transaction actually happened. Like we don't know which of the 6 months that it actually happened. But and it says it like masks the other ones, so you won't get a penalty for, you're only evaluated on the actual month, right? So like say, let me just go back to this. So let's say, you know, we have 6 predictions, but let's say this is the one that it actually happened. It's only going to evaluate our accuracy here. It's not gonna, it's going to mask these ones, so we won't get a penalty for that inaccuracy if there is. At least that's the way I understand it from what I read. Yeah. So, and then I guess the idea is when you get into the second round, you're gonna be like predicting housing prices that haven't actually been sold yet. You're using your algorithm, and then they're evaluating on real transactions in real time. So yeah, and if anybody wants to work on this with me, I'm gonna be working on it for sure, and it lines up with the course well, and then yeah, we can like come up with some stuff. But yeah, that's pretty much all I was gonna talk about.
Let's do it next year.
Yeah, 7 months. So it's enough time to learn and work and apply everything. Yeah.
I'd be down to have like a chat where we talk about different subjects. I don't know if I have enough skills to
Right.
but I'd be down to like
brainstorm ideas. Yeah. All right, I'll just finish this stop this recording.
Do I need to sign up with Kaggle though?